Good morning all of you. So today we are going to see the topic that is absolute and gauge pressure. So before studying about the absolute and gauge pressure, we will see three cases here. So let's take the first case. See in figure number first. You will see an imaginary liquid column. Here this is the surface of your fluid. Fill in the container. Out of this there is air. And below that there is water, which we consider as a fluid. In this fluid, we consider this as an imaginary liquid column. So this is an imaginary liquid column having cross section area A and height h. We will consider two reference points here, x1 and x2. So these are the two reference points. Now at the upper surface of this imaginary liquid column, there will be force exerted by the present fluid which is above this surface. So the force is nothing but F1, which will be exerted due to the upper liquid on the upper surface. Same way, this imaginary liquid column will have its weight. Because of its weight, there will be one more force, that is mg, which will act in downward direction. Now at the bottom, even some fluid is present which will try to exert the force at the bottom surface. That is nothing but F2. Now here the equation can be written as this F2 can be balanced by F1 plus mg. So I can write the equation as F2 is equal to F1 plus mg. So now by the definition of pressure, this F2 can be written as P2 into A. Similarly, F1 can be written as P1 into A plus M into G. Now, as we know the formula of density, that is density is nothing but mass upon volume. So, mass can be written as density into volume. Now whatever volume here we are considering, this volume is nothing but the volume of this liquid column. So here the volume of this liquid column can be written as rho as it is. This cross section area A into H will give me the volume of this imaginary liquid column. So instead of V, I can write here A into H. Once I get M here, I will insert in this equation. So this equation will look like P2A is equal to P1A plus value of M is rho A, H and G as it is. Now here H, this height can be written as x1 minus x2 because x1 minus x2 will give me the height of this liquid column. So I can write here the equation P2A is equal to P1A plus rho A instead of H, x1 minus x2 into G. At both the sides of this equation, A is common, so it can be cancelled out. And so last we get an equation P2 is equal to P1 plus rho x1 minus x2 into G. This P2 is nothing but the absolute pressure, means total pressure. Now here if I write this equation in this way, like P2 as it is here, and if I shift this P1 here, so it will look like minus P1 is equal to rho x1 minus x2 into G. If I say this is my equation number 1 and this as equation number 2. So here this is nothing but the pressure difference. This pressure difference is nothing but rho x1 minus x2 is nothing but the height into G. Now in second case, what is the difference? This liquid column was completely deep inside your fluid. Now here I have shifted this liquid column, imaginary liquid column at the surface of your fluid. Means the above top surface is lying at the surface of this fluid having cross section area A. Now, if we consider the amount of pressure exerted at the top and bottom, here you have seen this F1 was the force which was acting on the top surface and F2 was the force which was acting on the bottom surface. Same way, here P1 is a pressure which is acting on this top surface of imaginary liquid column. But as this surface is lying on the surface of this fluid, so this pressure is nothing but atmospheric pressure, which we denote by P0. Same way, this bottom of this liquid column is lying completely inside the liquid. So the pressure exerted at this bottom will be nothing but because of liquid, that is P. If we consider again two reference points, here is my x1 and this is my x2. Now, just see this diagram properly. If I say this is my coordinate system, here above this surface of this fluid, I will consider positive y-axis and below this I will consider negative y-axis. So, whatever height I am considering here, it will be in negative, that is minus h. So, here, let's write first thing that we have to see here. Here P1 is nothing but P0, that is atmospheric pressure. P2 is nothing but P, which is the pressure exerted by the present fluid inside at the bottom surface. X1, if I take a starting reference point, then I will take it as a 0. And X2 will be my height of this liquid column. As I have said, it is at negative y-axis, so it will be minus h. Now we have this fourth thing and we know equation number 1. So, by the equation number 1, here instead of P2, we are having P. Instead of P1, we are having P0, that is atmospheric pressure. Rho as it is, instead of x1, we are taking 0 now because it is the starting reference point. And x2 is nothing but minus h. So, now the equation here becomes, according to this, my equation number 1. P2 will be P. P1 will be P0 plus rho x1 is 0, so as it is, subtraction sign as it is, x2 is minus h and after that g. So this equation will look like P is equal to P0 plus rho, negative will become positive and this is my equation. So this is my total absolute pressure or total pressure, absolute pressure. If I want to calculate the gauge pressure, I need to do subtraction or difference between the atmospheric pressure and absolute pressure. Means if I write this equation as P and if I take this atmospheric pressure term at this side, so it will become P minus P0 is equal to H rho G. So this thing tells me about the gauge pressure. So gauge pressure means what? Difference between the atmospheric pressure and absolute pressure. And this term tells me that this is the total pressure or absolute pressure. So gauge pressure means any pressure that may be because of liquid or air. So here in this case we are considering this P as pressure because of this liquid. And P0 is nothing but pressure due to atmosphere. The difference between both this gives me gauge pressure. So I will take this as an equation number 3. Now in third case. In third case we are seeing this imaginary column, imaginary liquid column is completely above the fluid. Means this is my surface of the fluid and completely out there is air. So now I can consider this as a imaginary air column, not a liquid column. So whatever till now we have considered this density rho. This density was of water. So I will write here W, so it indicates that this is the density of water. But in this case, I will consider the density as of air because whole the column, imaginary column we are considering in air. So now in this case, again we will choose two reference points. This is the starting reference point or starting column and this is the ending reference point. In this case also, if you see properly, this bottom surface lies on the surface of the fluid. So the pressure here P2 will be nothing but the atmospheric pressure as this surface comes at the surface of the fluid. So P2 is nothing but P0. So here I will write P2 is nothing but P0. The upper surface of this imaginary fluid having area A has a pressure P1, and this pressure is nothing but due to air, that is P. So here P1 will be P. Again, if we talk about the two reference points, this is my starting reference point. So x1 will be 0 and x2 will be nothing but full height, that is denoted by d. Now, if we have P2, P1, x1, x2, again we will go to equation number first and we will substitute all this value instead of P2, P1, x1 and x2. So equation 1, instead of P2, now I will have P0, that is atmospheric pressure. Instead of P1, I will have P, that is pressure due to air column. Rho, that is the density. It will be now density of air because we are considering whole air as the imaginary air column here. So the whatever present fluid is inside is nothing but air. And here instead of x1 there will be 0, x2 will be d and g as it is. So now equation here will become, instead of P2 I will have P0. Instead of P1 here I will have P plus density of air now, not of water, x1 minus x2. x1 here it is 0 minus x2 means d and g as it is. Now this equation will be P0 is equal to P plus density of air. This is minus d into g. So this whole term will look like P0 is equal to P minus rho d g. So this is now my total pressure. But if I do difference, that is, if I do in this way, total pressure minus my atmospheric pressure, then this equation would look like in this way. So now in this case, this P gives me the total pressure or absolute pressure. But if I do the difference between two, that is total pressure means absolute pressure minus the atmospheric pressure gives me the gauge pressure. So this is my equation number 4. So in all cases you can see this pressure P, I can call it as a total pressure or absolute pressure. In this case also this P2 is total pressure or absolute pressure. But when I am doing difference, that is P0 means atmospheric pressure, means absolute pressure minus atmospheric pressure will give me the gauge pressure. So this three equation, that is equation number 3rd, 4th and here 2nd will give me the that is gauge pressure. So these three cases are very important. Thank you.